Okay, guys, so today we're going to take some very quick notes on layers of the earth and convection. And even though I kind of already went into convection, just to really make sure y'all understand how important it is in the process. Okay, so when we talk about layers of the earth, this is a review from sixth grade, but the earth is actually broken into three main layers. The core, which can be subdivided into outer core, inner core, the mantle, and the crust. Now, in sixth grade, you just called it the crust, but now in eighth grade, we're going to call it the lithosphere. And the upper part of the mantle is going to be called the asthenosphere. So go ahead and draw a very rough layer and, go inner core, which is a solid, outer core liquid, mantle, which is molten rock, which is a semi-liquid, and the crust, which is a solid shell lithosphere. Okay, so here's kind of a pie sample. Make sure that you do draw this in your notes and you kind of write some characteristics that, the inner core is 800 miles thick, mainly made out of iron and nickel. Outer core is 1400 miles thick, again, iron and nickel. The mantle, the thickest one, is 18 miles thick, and it flows with the consistency of asphalt. So think of it like that liquid rock. It is very viscous, which means very thick, and it moves very slowly. And then you have this thin orange, which is what we call the asthenosphere, which is the upper part of the mantle, and this is where most of the convection occurs. And then you have the lithosphere, which is this dark brown, and light brown, which is the crust. So let's talk about the lithosphere. The lithosphere is actually broken into two different types of crust. Oceanic crust, which you guess it, is the crust that's at the bottom of the ocean, and continental crust, which is the crust that continents are made out of, which is aka land. So go ahead and copy this picture in your C notes. And let's talk about some characteristics. Well, oceanic crust is thinner. And if you look at this picture, they're definitely showing you the thickness. It is a lot thinner, but it's also a lot denser. Because if you remember from the previous video, it is made out of basalt, which is an igneous rock because it's made from volcanic eruptions. And it's younger because it is created through seafloor spreading. So oceanic crust is thinner, denser, younger, and it's mainly made out of basalt. Continental crust, which is what you are standing on, is thicker, less dense because it's actually made out of granite and it is older. So you really need to understand that the lithosphere, which is a crust, which is what all the plates are made out of, is actually made out of the two different types. So if you look here in this image, you have your continental crust, which could be the mountains, and then you have your oceanic crust, and then your upper part of the mantle, which is going to be your asthenosphere. Just showing you the different shapes of granite, continental, basalt, oceanic. Okay, so let's talk about convection. Again, copy this picture in your notes. Remember, convection is the movement of heat in a circular motion. So we have to review density. When things heat up, the particles start to increase speed and they move a lot faster. And they also start to space out. So I want you to pretend that we wanted to take the entire school and I wanted everybody to get into my classroom. Okay? Because everybody is trying to get in here, it's going to be very crowded. So where are you going to want to do? Are you going to want to stay in here? Or are you going to want to leave? Where are you going to want to leave? Because it's so hot, you're going to want to space out. And because that, it makes things rise because they become less dense. Now that it's up here, away from whatever the heat source is, when particles get cold, they start to move closer together. Just kind of like when you get cold, you want to huddle up against somebody. It's going to make the object more dense, which is going to cause it to sink. And so when it heats up, it's going to rise. And when it cools off, it's going to sink. This circular motion is called convection. So think of water boiling. If this was a pot and we were boiling water, the heat source would be down here at the bottom from the coils. And if you ever throw spaghetti in a pot of boiling water, you'll start to see that it moves in a circular motion, which is convection. Okay, so here we go with our convection currents. You have your heat source And if you put some wooden blocks in there or macaroni, like I just said, you could see it moving because it's heating up, it rises, and then it cools off and it sinks. This is an example of the asthenosphere, like what is happening right here in the mantle. These wooden blocks are an example of the lithosphere, which are the plates, whether it's continental crust or oceanic crust. Now remember, this whole movement of convection explained how the plates were moving apart, which was what Wenger was missing in his continental drift theory. Okay, so here's the Earth's crust if made out of plates. The convection currents are in the mantle are what allow the plates to move. So let's pretend that I'm drawing some plates over here. If you look at this convection current, this plate would move to the left and this plate would move to the right, meaning these would be moving away from each other. Now, if I added another plate right here, based on this convection current, this plate would be moving downwards and this plate would be moving right and upwards, meaning these plates would be moving towards each other. So the reason why all the plates are moving and still moving to this day is because of convection currents that are occurring in the mantle. And it's because of that unequal heating in the core and that rising and falling of being less dense and more dense. Okay? So I'm actually, Miss Wheelis is going to do a demo on plate tectonic or on convection. So I'm going to go ahead and pause that. And so tomorrow in class, she'll start with the demo and then you'll go ahead and work on pages 5 through 7 in your plate tectonic book. Bye.